Hello and welcome to part 2 of oil and gas, power plants and industrial facilities engineering. In part 1 we established that we will interchange the term oil and gas between power plants and industrial facilities, although they may not be the same sector, but in terms of their magnitude and scale and complexity, they are similar, which is why we have chosen to adopt this term for talking about these three different sectors of engineering. Although as we progress, one of these will be dropped, and as well as we are going to elaborate on individual aspects of these engineering sectors, but it's best to adopt one terminology for this. So in part 1 we spoke about the various stages of oil and gas project management, and when we talk about project management, we are including all that has to do with engineering design from conception to execution and commissioning. So we talked about in oil and gas, it's kind of different because we are talking about 3 stages as opposed to 4 stages or 5 stages in standard project management, depending on which school of thought you belong to. So we looked at the stage 1, which was conceptual stage, stage 2, which was the feed stage, which is front end engineering design, and the last stage, which was the EPC stage, the engineering procurement and construction stage. So to have a more broader understanding of what was discussed, you can always go to part 1 of this video series. So today we'll be talking about part 2, which is on oil and gas, power plant and industrial facilities engineering. This video is based in part as a review of Herve Baron's oil and gas engineering guide, as well as other online videos on oil and gas areas, such as one which is done on Coursera, as well as the onshore structural design step-by-step calculations. So today we are looking at considerations for process flow design, process flow design properties and metrics, as well as process flow by purpose and fluid type. Then we are going to conclude on this talk, as well as give a brief introduction to what we are going to be discussing in part 3 of this series. So let's go into this course today. So considerations for process flow. Upon understanding the conceptual aspect of the project, when we go into the feed stage of management of this oil and gas project, there are 3 basic deliverables that are required, one of which is the process flow design, also called PFD, general arrangement drawing, GAD, and single line drawing, SLD. There are several other drawings that are required, but these 3 are sort of like the bedrock upon which all other documents are derived. So it's very important that these documents are generated. If you look to the right of this slide, you will see that there are some other drawings and documents that have been listed here, but these 3 are the basic that are required. In terms of carrying out the GAD drawing, it's not possible, or it's not really realistic to carry it out without the process flow diagram, because it's from the process flow you will know which equipment comes after which equipment, which process unit comes after which process unit. So you see here, process design basis, process flow scheme. These are different considerations in carrying out the process flow. In process design, you typically have the chemical engineer, petroleum, mechanical, electrical, piping and instrumentation. You hardly have the civil engineer at this stage of the project. If it's an oil and gas facility, you are going to have a lot of chemical, petroleum engineers and mechanical. If it's more of like a mechanical process facility, sort of like a power plant, you'll be having more of mechanical engineers involved in the process design. So this is basically some considerations in the process design of an oil and gas facility. So process flow design properties and metrics. In the process design, there are some basic parameters that are used for the design. Anywhere you go in the world, there are some equations that are standard that are always required in process design. For example, if you are carrying out design of a process for, let's say, crude oil, and if you are carrying out design for, let's say, steam, the kind of parameters that you'll be using is going to be different based on the state of the fluid. Also, the characteristics of this fluid also determine the kind of equipment that are being utilized in processing it. So the mass flow equation is one of the basic equations that is used to obtain sizing and dimension, and is used for design of equipment that are required in each processing unit of an industrial facility. So you can see here the mass flow rate, which is rho VA, where rho is the density, V is the velocity, and A is the area. So from this, all other equations and properties can be derived, or when other properties have been obtained through other thermodynamic equations, we are then able to input it into the mass flow equation to obtain other characteristics of the equipment and the system. So you see here other important fluid characteristics are the density, temperature, and pressure. There are various available tools and applications that can help with thermodynamic analysis, that when you have one or two or three or more characteristics of the fluid, you are able to impute it and ultimately obtain the unknown properties of the fluid, from which you'll be able to transmit to the mass flow equation and put in your characteristics. It is some of these numbers, when obtained, that are now placed on a chart. So at each inlet of any processing unit, at the inlet there are conditions, let's say a mass flow, the density, the temperature, the pressure, the purity of the fluid, and at the outlet there is also similar metric but varying values in terms of pressure, density, let's say the purity, temperature, and other information. In a process flow, it may be that when a fluid goes into a particular unit, there is split. Let's say you are going to remove some of the fluids from the gases. So when you carry out a separation, there's going to be a reduction of mass, let's say from the fluid. Let's say you want the overall mass is going to be reduced. So one part of the mass will go to fluid and one part of will go to liquid, while the other part of the mass flow rate is going to the gas. So you see how this split is going to happen, and based on conservation of mass, this continuously happens over all the processing units of the oil and gas facility. So you see here there are different process flow design for different plant types, whether it's oil and gas plant, whether it's a power plant. There are different process flow design schematic, which we are going to go over briefly. So for the case of process flow for an oil and gas configuration, we have different units, from vertical vessels, horizontal vessels, and the likes. So you can see here to the right crude oil distillation. So the presence or absence of certain equipment is determined by the type of fluid and the purpose of the plant. Also, the sequence is based on the purpose of the plant. For example, if you are carrying out power generation, more often than not, the turbine that is going to generate this electricity will come before the pump. For example, if you are running a system where the fluid is in a circular system, so there's a circulation of this fluid. So after the fluid has generated electricity, it goes to another unit and is pumped back again. For example, when you are boiling in an incinerator, you boil the water to steam, it goes to a turbine, it goes to the cooling system, and is pumped back. So there's a sequence of the kinds of installations. If it's an oil and gas facility, there are junctions where you will have a pump, but you're not going to have turbines because you're not generating electricity. when it comes to processing the fluid on an oil and gas facility. So this was taken from an online course on Coursera. Some basic prerequisites for oil and gas facility is the fractionating column. So you see here, like we have learned from chemistry right from high school, we've seen different fluids being extracted at different temperatures. So looking at process flow, there are additional features that are usually included in the processing units for oil and gas operations. So it could be breaking down or heavy hydrocarbons to obtain important compounds. There's usually a specific quantity when you carry out fractional distillation of crude oil, some of which go to kerosene, some go to petrol or Gulf fuel gas for vehicles, some go to diesel and the likes. So there will be times where you want to obtain either more quantity of the vehicle fuel, or you want a more purer hydrocarbon that's good for vehicles. So it's possible to carry out cracking and reformer and other such operations in order to achieve this purpose. Because these heavier oils are simply also hydrocarbons that can be broken into smaller units that are more useful to the processing company. So for natural gas itself, because there are some wells that produce mainly natural gas, so natural gas is extracted from this well as opposed to the whole of crude oil and natural gas. Sometimes it's just natural gas, and in this case you are processing just the gases. So this is a typical natural gas treatment according to Herve Baron, which goes from the raw gas to petroleum separation to acid gas removal. In the first stage you also have condensate separating, then you have dehydration, natural gas recovery, dew point control, gas compression, and it then goes to sale of this gas. So you see here a process flow for natural gas refining. So from the first stage where the raw gas is gotten from the well, you see liquid removal, wastewater removal, then the fluid continues in the process to acid gas removal. So there is removal of various other elements, so we can call them impurities because it's not what is needed from the raw gas. So at the end of the process, after the natural gas processing, you see ethane, propane, butane, and pentane. So this is a typical example of flow process for a natural gas refining process. You see here that they may not have used the standard symbols for process flow design. So there are standard symbols for process flow design which is available in several literature. It can be searched upon, but the first drawing we showed for schematic of an oil and gas operation is based on its software, and various softwares also have these symbols for process flow design. So when it comes to power generation, there are also various symbols unique to it as well. So here we are considering a geothermal power plant. So there are various other power plant types. It could be hydropower plant, it could be steam power plant, and the likes. So but here we are looking at geothermal. So you have the well from where the hot water comes from, and there is some separation units, which is that vertical vessel you see. Separation could also be a horizontal vessel, but you see different components. Although you are seeing different units at the top and the bottom, they look similar. Do not bother about it because it's sort of like a binary plant with different components. They are flashing and the rest. Those are just technical areas, but basically looking at only the top segment of this process flow, you can see the turbine, which is labeled ST, and you can see some other components along the process flow. So this is an example of a power plant process flow drawing for geothermal power plant. So we've looked at various areas. We've looked at process flow design as being the basic step that leads to all other designs in an oil and gas feed stage. Also, we've looked at process flow design parameters, how important they are and how basic that it's easy to always find your step once you know the mass flow equation. And also we looked at process flow based on the fluid type and the purpose of the facility, which is also important, and it determines the kind of equipment and the usual sequence of the process flow drawing. So in part 3 of this video review, we are going to be looking at equipment types for the various facilities. So until next time, Upper Delta Tech, where we create for better living.